Hi everybody. Today we're going to take some time to look at the exercise worksheet for section 7-3, which is similar triangles. And what it's going to require us to do is identify why a pair of triangles is similar and also be able to write the similarity statement accurately. So those are two things it's asking us to do. So there's three reasons triangles could be similar here. We have angle, angle, side, 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 and side, angle, side. And each of these three reasons was detailed in the notes video for 7-3 if you want to go back and watch that. So let's get started. We have these two triangles here. We have this triangle inside the larger triangle. So what we want to do is see if the corresponding sides are proportional. And we're going to go ahead and test that out. So I'm going to start with the smaller. Actually, I'll do small over big. I'm going to write that here so I don't forget. So for this particular problem, we're going to do small over big. And I'm going to use colors to illustrate that. So the small is going to be the blue. So small will be here. That's 8, right? And small over big. Big is going to be red. So red's right here. So here, some folks might be tempted to say that the red is 3.2 or 3 2/10, which it's not. It's actually this added together. The red is the sum of these two values, which would be 11.2 or 11 2/10. Okay. Let's try to check out the other ratios. So small down here is going to be 5. 5. And then the large is going to be the red. I'll zoom in a little better so you can see here. Okay. And that's, let's see, so the small is going to be 5. And the large is going to be 5 plus 2, which is 7. So again, a lot of folks, they look at this and they say, oh, the red is 2, but when you use the colors, I actually think it makes a big difference in terms of visually being able to see this. So if you don't have a printer, what I'd recommend is drawing the triangle, and then, like I said before in class, having some colored pencils really makes a big difference. I use pen just because it's easier, it shows up better on the camera. I wouldn't recommend using a pen on your own for these. So the last one, small over big, so small is blue, so small is going to be 10, and the big is going to be 14. And you can see the triangles taking shape here. Okay, so now we're going to go ahead and check these ratios to see if they're the same. Now, they don't simplify easily, so we're going to kind of cheat here and use a calc. I guess it's not really cheating, but we're going to see if we get the same ratio. So 8 over 11.2, and that's this gobbledygook number. It's just, we can do that, but we're not going to say what it is because that's just not necessary. 5 over 7, same value. And then 10 over 14, well, this should be the same value because that's just 5 over 7, not simplified yet, right? And there we go. So they're all the same value. They're all the same proportion. So the sides are proportionate. So we know these triangles are similar because of side, side, side. So we've established that. And now we need to write the similarity statement. So I'm going to go the small one first. And I'm going to go U, W, Y. So U, W, Y. Okay, and I'm going to go in the same order, U, X, Z. Now I did that rather quickly. What is important is that the corresponding sides match up with the letters. So for example, UW right here should match up with UX, which it does, the first two letters. YW should match up with XZ, which it does. And then the first and last, UY, should match up with UZ, which it does. So that's how it works. All right, let's try the next one. Now this one we have no sides. Okay, so it's not going to involve it can't really involve either one of these two. If they're going to be similar, it's going to be because of angle, right? So now we may not have enough information, by the way. These are not all going to be similar, and I have a feeling this may be the case for this one. So the smaller triangle, I'm going to go ahead and draw it with the colors here. So the smaller triangle will be blue. We're going to keep it that way throughout the video. And the bigger triangle is red. Okay. Now what do they have in common? Well, they definitely have the same angle in common. That should be, this angle right here they have in common. And that's about it. That's literally all we have. Now if these lines were parallel, it'd be a different story because we'd have some corresponding angle as a transversal and and we'd have some angles that are congruent, but we're not told that these lines are parallel here, so we don't have enough information. So not enough information. Okay, let's look at the next one. So here we have an angle. So an angle here and an angle here. So the angles there are congruent. We have a side here and a side here. So let's go ahead and check that proportion. So the small will be on top, so 6/10. And then we have a side here, which is 9. And a side here, which is 9 plus 6, which is 15. Okay, so let's see if these are going to be the same. So use a calculator. You know, I'm actually for this one I'm not going to use a calculator. I'm just going to simplify these. These are both divisible by 2, and I'm going to get 3/5, which is 0.6 or 6/10. I'm going to divide these by 3, and I'm going to get 3/5. So they are the same ratio. They are proportionate. So these sides are proportionate to these sides, and we have an included angle. So it is side angle side, as you can see here. So side angle side works. Awesome. Okay, and then we need to put the similarity statement in order. So I'm going to go BDF for the first one. So BDF. So it's going to be BCA. And there you go. All right, let's look at number 4. So here we do have parallel lines. So this is actually, let's just rewind for a second. This looks a lot like this one. It's turned on its side basically, and these are parallel. And these being parallel are actually going to be really important, which you'll see why in a moment. So, one second. Okay, so let's establish what we have in common. So we have these two parallel lines, excuse me, and this side is crossing them, and this side is crossing them. And what that allows us to do is actually identify some angle relationships. I'm gonna do something a little strange here. I'm gonna extend these segments, and I'll show you why in a moment, because I think then maybe it'll become obvious to folks, or more obvious. So I'm gonna extend those. I'm gonna extend that. Okay. So we've extended that. Now I'm gonna extend this parallel line. And this line, sorry, these two parallel lines. Okay, so these lines are parallel. For a moment, let's just focus on this line segment up here. So I'm just going to block that off actually for now. So there's angle relationships here. This actually, if I rotate it, right? Check this out. If I rotate it, this looks just like our exercises from earlier in the year when we have parallel lines and a transversal, right? So these are two parallel lines. This is a transversal, and there's a whole bunch of angle relationships that exist here, right? We have same side interior, we have alternate interior, we have corresponding, we have alternate exterior, right? We have all those angle relationships, right? And a bunch of them are going to be congruent to one another. And the ones that are important to us are the ones inside these triangles here. Now I'm going to draw the triangle here because it's easy to get lost with these additional lines I just extended. So that's the small triangle, and this is the big triangle. Okay. Now what we want to see is if either one of these pairs of, that's actually, that angle is congruent to itself. So let's go ahead and establish that. They both have J, right? Both, and it's funny, I didn't actually see that till I drew it. Even myself, I didn't see that angle in my head till I drew the blue and the red. Kind of an advertisement for colored pencils here, right, guys? So yeah, so we're going to draw that angle. That we know there's an angle that's congruent for both triangles. Okay. So all we really need to do is find one more angle, and we got angle. Okay. We don't really have any sides that are matching up. We have no values on the sides, so the only possibility of these triangles being similar is going to be angle similarity. So what we're doing is looking for another pair of angles that's similar, and we have them. We actually have a choice. We can either go with these two or those two, and I'll explain why. This angle here corresponds with that angle, right? If you look at this as a transversal crossing two parallel lines, we know that these angles correspond, and we know when the lines are parallel, the corresponding angles are going to be congruent. Therefore, we have a pair of angles here because this is obviously congruent to itself, and these are congruent to each other, all right, because of corresponding angles when you have parallel lines crossed by a transversal. You could say the same thing down here. These are going to be corresponding to each other. These lines are parallel. This technically it's really a transversal, and they'd be congruent. So this is angle-angle. So angle-angle similarity. And I'm going to go blue first, so JKP, and then JLM. Okay. All right, let's look at number 5. So we have two sides and an angle. Now the angle here is congruent to the angle there. So this triangle is definitely smaller, so we'll put blue here and red here. Okay. And then we have a pair of sides, right? We have a side here, side here, side here, side here. Now that could be side, angle, side. It can't be angle, angle because we only have one angle, right? We can't have side, side, side because we only have two sides. So the only possibility of this working is side, angle, side. There's a problem with that though. Here, the angle is included. It is in between these two sides. Here it is not. If this angle was down here, well then we'd have a shot at side, angle, side. Then what we could do is we could actually create a proportion. We could say 2 over 12 is equal to 4 over 18 and see if that works. But we don't even need to do that. We know we don't need to do that because the angle is not included. It is not in between the two sides. So therefore this is not enough information here. So not enough information. Okay. Number 6. So they give us two angles here, they give us two angles here. One's the same, and I don't know which one's bigger than the other, so I'm just going to pick this one on the left, the smaller one. So those are congruent. These are not congruent, but we don't know what this third angle is. Let's find out what this third angle is. We're going to use the angle sum theorem. So we're going to add these together, subtract from 180, and that should give us the remaining angle. So we're going to do 68 plus 47, carry the 1, so that's 115. I'm going to subtract that from 180. What am I doing? 115. And that's going to be 65, yeah. So this is going to be 65 degrees. All right. This one, let's see what this angle is. So 47 plus 59. That's going to be, carry the 1, 16, 106. So this is going to be 74. So these only share one congruent angle, and that's it. So therefore, it's just not enough information. Okay. So that's the first side. Let me zoom out here so you can see it all at once. And like I said, this is definitely going to be a longer video because I want to take my time going through these with you guys. I'm hopeful that that alleviates concerns on the first 6 problems. Okay. If you have any further questions on those, please don't hesitate to ask, either in class or in Google Classroom, obviously. Let's look at the back 6. So let's look at this one here. Identify the similar triangles and find each measure. Okay, so this is a little different. So this is asking us to identify the similar triangles. So we're told they are similar. That's not in question. And identify what's missing. So we're going to solve for a value here. So we're solving for this missing side. And we're told that these triangles are similar. We're also told to write a similarity statement. All right, well, we know they're similar because of angle, angle. Look, so this angle and that angle, those are both vertical angles, therefore they're congruent to one another. And we're told these angles are congruent to each other, so we have angle, angle. So that's cool. This side, let's see, angle, angle, side, angle, angle, side. So this side matches up with that one. We're going to make the top triangle blue and the bottom triangle red. So x is going to be on top, and red is going to be on bottom, so 12 will be on bottom here. So x over 12. And we're going to have, again, since this blue is on top, this blue will be on top as well. So we're going to say 4. And we know they correspond because they're in between the same two angles. So 4 over the red value, which is going to be 6. And now we cross multiply and solve. I'm going to simplify this first because I like working with smaller numbers. I'm going to divide these by 2, so this is going to become 2/3. You don't need to do that, but I just like to do that. Let's cross multiply here. So 3 times x is going to be 3x, and 2 times 12 is 24. We're going to divide both sides by our coefficient here, which is 3, and x is going to be 8. So we identified our missing value. JK is 8. They don't give us any units, so we don't have to worry about that. We do have to write our similarity statement, so I'm going to go 2, 1, none. In terms of, when I say 2, 1, none, I mean the number of arcs, right? So actually, I'll put the red one here. So 2, 1, none. So LPM. And here I'm going to do the same thing, 2, 1, none. So LJK. Okay, let's look at number 8. So number 8, we have this piece here. We're looking for this x value here. We know the whole thing is 20. And we have these sides that correspond. Okay, so the smaller one's going to be blue. So we're going to go blue is x. So x is on top. Top of red, which in this case is 20. Okay. And then blue will be this one, 12. Oops, here you go, 12. On top of red, which is 16. Okay, we're going to cross multiply and solve. Before I do that, though, I want to simplify this. These are both divisible by 4. So I'm going to write x over 20 is equal to 3/4. And now I'm going to simplify. Now I'm going to cross multiply, rather. I just like working with small numbers. You don't need to do that. You can cross multiply 12 with 20 and 16 with x. You can do that. I just personally like doing this first. So x times 4 is 4x. And 20 times 3 is 60. We're going to then divide by our coefficient, which is 4. And x will be equal to 15. Okay. And it's asking us for ST. Okay, so we have to be careful. It's not asking us for ST. It's not asking us for x, because x is actually QS. It's asking us for ST, which is the difference between 20 and x. Like this is whatever 20 minus this is, right? So we have to figure that out. So we're going to do 20 take away, because this is actually part of it, right? Whatever x and this value adds up to 20. So we're going to say 20 minus 15 equals 5. So ST is actually 5. And again, there's no units of measurement given to us. Okay, so that could be tricky if people just stop at x, which some folks might. And now we're going to write our similarity statement. So we're going to go small over big. So QSR and then QTP. Okay. All right, let's look at the next one. Number 9. So we have two triangles that have angle-angle similarity, and we're going to go, okay, so we have 3 sides, and we're looking for HJ and HK. So HJ and HK are these 2 values here. Okay, so HJ, we're going to go, I think this, see, this is definitely bigger, so we're going to go red here and blue here. Oh, sorry, yeah, red here and blue here. Blue's always smaller. So here, we'll find x first. So JH is the one side between the 1 and the 2 arcs. The 1 and 2 arc over here is this one here. Okay, so we're going to have blue over red, so we're going to have 12 over 4x plus 7. And then we want to pick a pair of sides that doesn't have a variable in it. So we're going to pick 25 since this other side has x in it. So we're going to put 25 here. And 25 is going to be on the bottom over here because the red's on the bottom. And this is between the 1 and the none. So the 1 and the none here would be 20. So that would be 20. Okay. And we're going to cross multiply here. Oh, before I do that, actually, hold on. Before I do that, we're going to simplify that. So we're going to divide the top and bottom by 5. So 12 over 4x plus 7. And that's going to be 4/5. Okay. And we're going to cross multiply. And yeah, okay, so we're going to cross multiply that. And let's see, 12 times 5 is 60. Actually, I'm going to pause for 1 second here. 1 second, guys. Okay, so we're going to cross multiply that. So we have 60 here, and then 4 times this. We're going to write it out. So 4 times 4x plus 7. Now you could solve this two different ways. You could divide both sides by 4 or distribute it. We're going to just distribute it, although I think I would prefer to divide both sides by 4, but I think we're going to stick with this just for the purposes of this video. So 6 equals 16x and plus 28, because we're multiplying here, right? So now this is the two-step equation. So we're going to subtract 28, right? And that's going to give us, what, 32? Yep. And divide by our coefficient, which is 16. Running out of room here. X is going to equal to 2. So because x is equal to 2, we can now plug it in and find our two missing values here. So I'm going to do that over here first. I'm going to simplify this. I'm going to evaluate. So we're going to plug in 2 for 4x. So 4x plus 7, and this is hj. So 2 is going in for x, and we're going to follow order. Ooh, I'm off camera here. Sorry. We're going to follow order of operations. So 4 times 2 is 8. 8 plus 7 is 15. So we have 15 for our hj. So hj is equal to 15, distance. And yeah, so this technically means the distance from h to j is 15, not the line segment. Anyway, all right, let's do the next part. Next part's going to be hk, which is 6x minus 2. And 6 times 2 minus 2, 12 minus 2, which is 10. So hk is equal to 10. All right. And that's it. So now we just need to write the similarity statement. So let's see. We're going to go 1, 2, none. So 1, 2, none, and red's going to be the second one. So jhk, and then 1, 2, none. So it's going to be qnp. Okay. Awesome. All right, so I have to get going. So here's what we're going to do. I want to finish these, but I'm not going to have time to finish this video because I have to get some other stuff done. So I'm going to post a second part to this where I'm going over these last 3 problems, okay? All right, thanks guys.